A device occupies the right palm. Surface temperature 41.8 degrees Celsius. Palm skin baseline prior to contact 33.2 degrees Celsius. Temperature differential 8.6 degrees. Contact area 40 square centimeters. Infrared imaging confirms heat flux direction. Device surface to palm tissue. Transfer rate measured 0.6 degrees per minute palm temperature increase during sustained contact. Continuous hold duration 15 minutes 32 seconds. Thermoreceptor populations engaged. Warm sensitive nerve endings, elevated discharge frequency above baseline. Cold sensitive fiber activity suppressed below resting rate. Neural adaptation progressing. Initial thermal sensation at contact onset, acute warmth perception. Sensation at minute 15, reduced to low-level background awareness. Palm surface temperature at contact zone reaches 39.4 degrees Celsius. Thermal equilibrium state approaching but incomplete. Device internal temperature 44.3 degrees Celsius due to processor activity and battery discharge heat generation. Environmental ambient temperature 22.1 degrees Celsius. Device lacks active cooling infrastructure. Heat dissipation, passive conduction only. Palm tissue functions as biological heat sink. Microcirculatory response detected via thermal imaging. Local capillary bed vasodilation measured. Blood flow to contact region increased 29% above baseline perfusion rate. Metabolic activity elevated in tissue zone accepting thermal load. Device generates continuous heat. Palm accepts load. Contact sustained. Temperature gradient narrows incrementally. Device placement transition from palm to external surface. Destination, table positioned 40 centimeters lateral to body midline. Separation timestamp, 14/18/27. Prior continuous contact duration, 15 minutes 32 seconds. Heat transfer pathway, terminated at separation moment. Palm surface temperature at contact cessation, 39.4 Celsius. Surrounding air temperature, 22.1 Celsius. New thermal gradient established, 17.3 degrees between exposed tissue and ambient environment. Thermoreceptor neural activity does not immediately reset to baseline signaling state. Warm sensitive receptors maintain elevated firing rate for 236 milliseconds post-separation. Cold receptors suppression persists for 189 milliseconds before ambient air contact triggers reactivation. Afferent nerve fiber traffic continues transmitting heat presence signal despite tactile mechanoreceptors confirming contact absence. Sensory channel conflict detected. Thermal modality signals sustained warmth, while pressure sensors register void state. Hand configuration, palm orientation upward, digits in relaxed extension posture. Visual inspection confirms empty palm space, no object present. Proprioceptive feedback registers absence of mass loading. Thermal sensory channel reports ongoing warmth sensation. Phantom heat duration 236 milliseconds. At 236 milliseconds post-contact cessation, cold receptor activation commences as ambient air molecules contact skin surface. Tissue cooling initiates. Warm receptor discharge rate begins rapid decline. Complete thermoreceptor reset to baseline signaling state, achieved by 423 milliseconds post-contact cessation.
Thermoreceptor reset latency generates task performance disruption. Experimental sequence initiated. Device held continuously 14 minutes. Removed at timestamp 15:03:41. Reset lag measured 242 milliseconds. Immediate post-removal action attempted. Grasping ceramic mug containing heated beverage. Mug exterior surface temperature 70.2 Celsius measured via contact thermometer. Expected thermal sensation on contact, intense heat perception. Observed initial sensation, attenuated heat awareness. Thermoreceptors remain calibrated to prior device baseline temperature. Accurate heat perception onset delayed 171 milliseconds beyond initial mug contact. Safety implication identified. Hand contacts surface exceeding safe tissue temperature threshold, while receptor array signals reduced thermal threat level. Nociceptive pain receptor activation delayed relative to standard protective reflex arc timing. Normal thermal withdrawal reflex latency 118 milliseconds from noxious stimulus detection. Observed withdrawal latency during reset window 291 milliseconds. Temporal extension 173 milliseconds. Tissue exposure to excessive heat prolonged beyond normal protective response duration. Burn injury risk elevated during thermoreceptor vulnerability window. Second experimental trial. Device hold duration 10 minutes. Removal timestamp 15:19:08. Immediate reach executed toward metal stylus object. Stylus temperature 8.4 Celsius, significantly below room temperature. Thermoreceptor adaptation state, configured for warm device baseline temperature. Cold object contact initially registered as thermally near neutral. Veridical cold stimulus detection delayed 219 milliseconds post-contact. Motor grip force adjustment insufficient during detection delay interval. Consequence: stylus slips from inadequate grasp. Object drop event confirmed. Daily reset event frequency 31 occurrences. Individual event duration 240 milliseconds mean. Cumulative daily thermal state confusion interval 124 seconds total. Task execution attempts coinciding with reset windows 10 per day average. Task disruption rate 61% of temporally coincident tasks show measurable performance degradation.
The isolated measurement variable, thermoreceptor neural signal decay latency following stimulus cessation, mechanical contact state, absent after device removal, thermal energy source, removed from system, neural discharge activity, persists beyond stimulus termination, persistence duration, 240 milliseconds mean across measurement trials. This temporal lag constitutes the primary traced parameter. Warm sensitive receptor physiology, characterized by slow adaptation kinetics, temporal response function, exponential decay with time constant tau equal to 87 milliseconds measured. Post-stimulus removal, mathematical model predicts 3 time constants required for approach to spontaneous baseline discharge rate. Calculation: 3 multiplied by 87 equals 261 milliseconds theoretical. Empirical measurement across trials: 240 milliseconds observed mean. Deviation magnitude: 21 milliseconds attributed to biological variance in receptor population response characteristics and measurement precision limitations. Cold-sensitive receptor dynamics, faster recovery kinetics profile. During contact phase, activity suppressed substantially below baseline firing rate. Suppression release latency: 191 milliseconds mean observed. Ambient air thermal stimulus initiates cold channel activation upon tissue surface exposure. Warm channel deactivation process, slower temporal profile. Overlap interval: 49 milliseconds duration, where both receptor classes signal above resting baseline simultaneously. Perceptual consequence: thermal sensation ambiguity, neither clearly warm nor clearly cold state classification achievable. Sensory system interpretation: unstable during overlap window. Tissue thermal mass, not primary determinant of perceived delayed duration. Surface temperature monitoring via contact thermistor array. Cooling rate: 1.3 degrees per second observed upon air exposure onset. Physical temperature change velocity, rapid relative to neural response time course. Delay mechanism resides in thermoreceptor repolarization kinetics and synaptic neurotransmitter clearance dynamics, rather than tissue thermal inertia properties. Device contact established in palm. Hold duration 9 minutes continuous. Device surface temperature 42.1 degrees Celsius. Palm thermoreceptor populations achieve adapted steady-state firing pattern. Device removed at timestamp 16:31:15. Placement location: desk surface. Reset interval window 240 milliseconds. Concurrent action: keyboard task initiation. Hand contact with plastic keycap surfaces occurs at 93 milliseconds into reset window timing. Thermal perceptual expectation: carryover warmth from device contact. Actual thermal stimulus: room temperature plastic surface. Perceptual mismatch consequence: keycaps register subjectively cooler than baseline typing experience due to contrast with thermal phantom. Typing motor rhythm significantly disrupted. Initial 6 keystroke sequence execution velocity 39% below normal cadence baseline measurement. 13 seconds elapse post-device removal. Thermoreceptor populations, complete reset cycle to baseline state. Resting thermal awareness fully restored. Device retrieval action, different unit selected. Surface temperature 38.3 degrees Celsius, 3.8 degrees cooler than previous device. Palm contact initiated. Tissue heating process recommences at 0.5 degrees per minute rate. Hold duration 7 minutes. Removal action executed at 16:42:07. Reset window, 240 milliseconds. Object interaction attempt during reset. Insulated water bottle. Bottle exterior temperature, 17.9 degrees Celsius measured. Bottle grasp attempt occurs at 138 milliseconds into reset interval. Thermoreceptor signaling state. Residual device temperature baseline reporting persists. Actual bottle surface temperature, 24.2 degrees below device contact baseline. Thermal contrast magnitude, perceived as exaggerated due to receptor adaptation state mismatch. Cold shock withdrawal response, triggered prematurely by contrast amplification. Bottle release, occurs before secure grip establishment. Liquid containment integrity compromised. Spillage volume, 57 milliliters lost to work surface. Third interaction sequence cycle. Device hold, 11 minutes duration. Surface temperature, 41.9 degrees Celsius. Removal completed at 16:58:33. Reset lag, 241 milliseconds. Task initiation, none attempted during vulnerability window. Hand positioning maintained in stationary rest configuration. Thermoreceptor decay process proceeds without motor task interference. Baseline achievement occurs without associated task execution errors. Reset completes absent consequence beyond isolated temporal sensor delay.
Multi-day longitudinal observation protocol implemented. Day 1 measurement summary. Device interaction events 28 total. Hold duration range 5 to 16 minutes per interaction. Device removal events 28 corresponding. Thermoreceptor reset occurrences 28, maintaining 1-to-1 correspondence. Task execution attempts initiated during reset windows, 9 instances. Task performance disruption incidents, 6 documented. Error classification categories: keystroke temporal coordination deviation, grip force calibration failure, producing object drops, exaggerated thermal startle responses withdrawal. Day 5 measurement summary. Interaction count 35. Reset window tasks 12. Disruption incidents 8. Day 11 summary. Interactions 43. Reset window tasks 15. Disruptions 10 recorded. Interaction frequency demonstrates consistent upward trend. Error rate magnitude maintains proportional scaling relationship. Range 58 to 66% of reset window initiated tasks exhibit statistically significant performance decrement relative to baseline execution outside reset windows. The thermal ghosting phenomenon stabilizes as reproducible state transition artifact with consistent temporal signature and disruption profile across observation period. Thermoreceptor adaptation capacity demonstrates no improvement via repeated exposure conditioning. Reset latency, day 1, 239 milliseconds mean. Reset latency, day 11, 241 milliseconds mean. Difference magnitude, 2 milliseconds, within measurement instrument error tolerance bounds. The 240 millisecond window represents fixed physiological parameter, neural adaptation constant values, immune to experiential conditioning or learning effects. Observed delay constitutes biological system constraint rather than behaviorally modifiable learned response susceptible to training. Motor prediction and control systems begin implementing compensatory behavioral strategy by day 17. Observation: reach movement velocity during reset windows reduced 23% relative to baseline velocity. Deliberate movement deceleration represents conscious cognitive override intervention. Task error rate decreases from 64% to 41% following compensation strategy adoption. Strategy efficacy confirmed through error reduction. Performance cost: task completion time increased 29%. Trade-off profile: accuracy improvement gained through execution speed sacrifice.
Task execution sequence performed in complete absence of device interaction involvement. Hand rests upon wooden desk surface material. Surface temperature 23.2 Celsius. Palm tissue temperature equilibrates to surface value over 12-minute contact interval. Thermoreceptor activity pattern registers stable cool surface contact. Adaptation process reaches completion. Neural baseline state established using cool surface temperature as reference configuration. Hand elevation from surface. Movement trajectory directed towards ceramic mug object containing heated liquid. Mug exterior wall temperature 68.7 Celsius measured. Contact initiation with mug surface. Thermoreceptor response dynamics. Immediate activation sequence. Warm sensitive receptor onset latency 42 milliseconds from contact onset. Thermal sensation quality. Heat accurately perceived within standard detection temporal window. Grip force modulation executed based on prompt veridical thermal feedback information. Object hold duration. Appropriate magnitude for elevated thermal temperature object safe handling protocol. Motor execution quality. Absent measurable error. Grip structural integrity maintained throughout interaction. Liquid spillage, 0 occurrence. Task completion efficiency, optimal baseline performance level achieved. Secondary object interaction sequence. Metal pen at ambient temperature equilibrium, 21.9 Celsius. Hand contact established with pen barrel surface. Cold sensitive receptor activation latency, 49 milliseconds from contact onset. Thermal sensation registration, mild cool accurately perceived within plausible detection temporal window. Grip formation motor sequence, executed without hesitation or delay. Writing task activity, initiated immediate post-grip. Pen manipulation motor control, precise coordination maintained throughout writing sequence. Thermal perceptual channel, non-interfering with primary motor control program execution. Task execution profile, baseline performance parameters specifications fully met. Tertiary object interaction, cardboard document folder material. Temperature measurement, 23.4 Celsius. Thermal sensation, neutral zone relative to ambient environment temperature. Thermoreceptor modulation magnitude, minimal deviation from resting baseline state. Object handling motor sequence, thermal awareness channel subordinate to tactile mechanoreceptor and proprioceptive position sense channels in control hierarchy. Task operation, folder positioning and opening manipulation. completion temporal profile, immediate execution, 0 delay detected, 0 error occurrence documented across sequence, device contact exposure, completely absent throughout this task sequence battery, heat source interaction, none present, thermoreceptor response characteristics, operate on veridical environmental stimuli within nominal specified latency parameters, phantom thermal persistence absent from all measurements, reset delay windows not applicable to sequence, motor control system function, uncompromised by thermal sensory confusion, baseline integrated sensory motor system function, fully preserved throughout complete task execution battery performance.
"90-day extended observation temporal window. Device interaction frequency count. Day 1 baseline 27 events. Day 30 interim 45 events. Day 90 terminal 69 events. Escalation magnitude 156% increase across observation span. Per interaction hold duration metric. Day 1 7.1 minutes mean. Day 90 10.7 minutes mean. Daily cumulative device contact time. Day 1 3.2 hours total. Day 90 11.8 hours total. Thermal exposure loading increased by factor of 3.7. Thermoreceptor reset event frequency. Day 1 27 occurrences. Day 90 69 occurrences. Task execution attempts temporally coinciding with 240 milliseconds reset windows. Day 1 8 instances. Day 90 19 instances. Daily aggregate thermal state confusion temporal duration. Day 1 6.5 seconds cumulative. Day 90 16.6 seconds cumulative. Task execution error count. Day 1 5 errors. Day 90 12 errors documented. Error rate per reset window concurrent task maintains stable range 56 to 63% across complete observation period span. Device surface operational temperature progression trend. Day 1 average measurement 39.6 Celsius. Day 90 average 43.8 Celsius. Elevated sustained operational temperature magnitude produces intensified thermoreceptor baseline shift. Receptor firing rate baseline more substantially elevated during contact. Reset lag absolute duration remains unchanged at 240 milliseconds, but phantom warmth subjective perceptual intensity amplified significantly. Thermal contrast magnitude between ghost sensation and ambient air temperature increased by 4.2 degrees.
Multi-device concurrent usage behavioral pattern emergence. 2 distinct devices utilized in alternating sequence. Device A, surface temperature 42.4 degrees Celsius. Device B, surface temperature 37.1 degrees Celsius. Rapid device switching behavior occurs with inter-switch intervals frequently shorter than reset window duration. Device A removed from palm. Reset lag window 240 milliseconds initiated. Device B acquisition and palm contact executed at 164 milliseconds into device A reset lag. Thermoreceptor signaling state continues reporting device A thermal baseline. Actual thermal input stimulus, device B at 5.3 degrees lower temperature. Thermal perception consequence, significant mismatch between expected and actual stimulus. Device B, subjective sensation, registers substantially cooler than objective thermometer measurement would predict. Grip force motor calibration incorrectly scaled based on erroneous thermal expectation. Motor execution errors accumulate systematically across repeated switching episode cycles. Day 90 device switching event frequency 23 events per day. Inter-switch temporal interval distribution analysis. 39% of switching events occur with intervals falling within single reset window. Thermal perception confusion event rate 8.9 events per day. Resulting task execution disruption incident frequency 5.2 events per day. Cumulative task execution efficiency metric progressively degraded by recurring thermal sensory state uncertainty and consequent motor calibration errors. Hand movement initiates reach trajectory toward device resting on table surface. Finger extension motor sequence begins approach vector execution. Motion arrest occurs prior to contact completion. The reach terminates in incomplete state. Phonetic vocalization production onset, phoneme wa detected. Vocal fold vibration arrests mid-phoneme. Brief residual acoustic echo recorded in ambient field. Complete word formation does not occur. Background environmental acoustic tone sustains at low frequency band. Constant amplitude maintenance verified across measurement interval. Tone cessation event occurs without gradual amplitude decay transition. A brief silence follows. Thermoreceptor neural activity comprehensive logs document robust cyclical adaptation behavioral pattern. Device contact events, high daily frequency. Device removal events, correspondingly high frequency. Reset temporal window temporal length, 240 milliseconds per discrete event. Daily event occurrence count, 69 by observation terminal point. Thermal perception accuracy functional range, restricted to temporal intervals falling outside reset window boundaries. Task executions attempted during reset states subject to systematic disruption. Disruption occurrence frequency scales proportionally with device interaction rate increase. Reset temporal window absolute duration physiologically fixed invariant parameter. Device operational temperature magnitude rises with increasing usage intensity and duration. Thermal contrast perceptual magnitude amplifies progressively. Confusion subjective perceptual intensity increases, while temporal signature profile remains mathematically invariant. The documented pattern recurs cyclically with each device contact establishment and subsequent contact separation event.